In this video, I'm going to give a short introduction to the fat-soluble vitamins. So here I have pictured the molecular structures of the fat-soluble vitamins and the water-soluble vitamins. I will get to the water-soluble vitamins in future videos, but first, after this short introduction to the fat-soluble vitamins, I'm going to go through the biosynthesis of uh, all of these fat soluble vitamins in the next few videos. And so vitamins are molecules that are essential for us to get from our diet because we do not make them ourselves. Well, humans do make the D vitamins using sunlight, but we also get this from our from our diet. Excuse me. Uh, but these other things like vitamin A, vitamin E, and there's actually two types of vitamin E. There's alpha and gamma tocopherol, which are the E vitamins. Uh, so vitamin K, there are multiple ones. They have K3 and K1 here. There's also a K2, and that just has to do with differences in this chain here, where this just has a methyl group here. This has this long chain. K2 has a different chain on here, but uh, they're all hydrophobic chains, which is something you can see is common to at least three of these different fat-soluble vitamins. The vitamin A, E, and K all have these hydrophobic chains on them. Vitamin D is a little bit different. This is actually more closely related to cholesterol. And like I said, it's also the fat-soluble vitamin that humans can produce, but we also get it from our diet, which, given that we don't get that much sun in our sedentary lifestyle, it's actually very important to get enough of it from our diet. But the vitamin A, E, and K, as we will see in the next few videos, all have some crossover in their biosynthesis. And so that's why I'm going to cover those first and then do vitamin D sort of on its own as the fourth video. Because usually when people talk about the fat soluble vitamins, you'll hear them talk about ADEC, which is vitamin A, vitamin D, vitamin E, vitamin K. But vitamin D I've sort of singled out and will do the video on last. I'm not going to go through the water-soluble vitamins right now. Like I said, I will do that in a future series after I get through the fat-soluble vitamins. But before we get to videos about the biosynthesis of fat-soluble vitamins, I thought I'd just go through a little of the nutrition about them. Well, first here we can see vitamins can be can be separated based on whether they are soluble in oil or soluble in water, which means they can dissolve in those solvents. So we get the fat-soluble vitamins here. Once again, we have A, D, E, and K. And then these can be broken down further into the vitamin D2 and D3, to the vitamin K1 and K2. As we can see here, there is more breakdown in the water-soluble vitamins. So we have the B complex vitamins. Well, vitamin C is also water-soluble, and then there's the vitamin B, which then can be broken down into thermolabile and thermostable. And so thermostable just means that it's stable in heat, thermo meaning heat. And then you can see here we have these different B vitamins. I also have here, because I'm going to also in the future do videos on the the minerals, the major minerals and micro minerals. So that's just broken down into minerals that we need sort of quite a bit of, and then minerals that we need just very trace amounts of. So for the major ones, you'll probably recognize things like calcium, magnesium, potassium, sodium, chloride, but there's also sulfur and phosphorus that we need, which those are not really minerals in the strictest sense because those are not metallic or if you look at a periodic table, uh, so pretty much all of these minerals sort of lie. There's sort of a diagonal there. They all lie on this side, whereas sulfur and phosphorus lie on this side, which are more of the sort of, I guess you could call them organic type molecules. But these are atoms, these are elements that we do need from our diet. And so first I'll talk a little bit about vitamin A. So I just have here there's these sort of two forms of vitamin A depending on uh, the re, the redox state of this functional group. This here is an aldehyde, and this is an alcohol right here. Um, and so one thing to notice in both of these is that we have these conjugated double bonds, which means that it alternates from double to single to double to single over and over like that. And one thing you will notice if you get into organic chemistry is that when you have these conjugated double bonds, this one also counts, even though it's in the ring, it's still double, single, double. As you add more and more of these double bonds, you start moving the absorption out of the UV and into visible light. And so what that means is your compound will be go from being sort of a more white looking substance to being some kind of colorful substance. And that's what I have here is we can see the absorption spectra of different, well, they call these pigments, and that's kind of what the definition of a pigment is that it's a molecule that has these conjugated double bonds like this, and that gives them different properties when they interact with light. And we can see here that this also shows the different types of chlorophyll, which are also conjugated double bond um, uh, molecular species, but then beta carotene, which is the precursor to vitamin A, the precursor to retinol. And we can see that that's the solid line here, that is absorbing in sort of this dark green, light blue sort of area, and in this sort of dark to light red area. And we see that it does not absorb here in this orange area, which means that orange is not being absorbed, and that's why things that contain beta carotene appear orange. Sort of the quintessential thing is the carrot. Everybody knows carrots are orange, and that's why they appear orange. It's also why leaves in the fall, when they start losing their chlorophyll, they start appearing in these sort of yellow and orange and red colors, is because they contain beta carotenes that once you lose the chlorophyll, then it will start appearing more orange and red and yellow colored. All right, down here, so this is just the change from beta carotene, which is usually the dietary form of vitamin A, and then that is cleaved on this bond here to generate using this 15-15 prime dioxygenase, which I'll go through in future videos here. Uh, and so that turns it into this retinal, and then this dehydrogenase, which was this reaction going up this way here from retinal to retinol, turns it into the the vitamin A species. Um, and so over here, I just have some tables that I got from Wikipedia that show some of the sources here of vitamin A, and this is the RDAs based on age, and so we can see that infants need quite a bit less, obviously, than adults. And we see that they also have the upper limit here. So vitamin A is not a vitamin you want to get too much of. It can actually be toxic if you get too much of it. And so the upper levels here are listed here. And so, for instance, males over 19 years of age need about 300 micrograms per day, or 3,000 rather. Same with females. There doesn't seem to be much difference there. Um, so they do have pregnancy and lactation here, which pretty much seems like it's the same. Uh, I guess it's just to point out that it doesn't change depending on those states. But we can see here that children ought not get too much of it, and infants even less. Over here we have sources. So beef liver. So liver is a high source of vitamin A. In fact, I think are some animals whose liver has so much of it that it can be toxic. Uh, I've heard this before, but maybe it's wrong. But I've heard that polar bear liver uh, is actually has so much vitamin A in it that if you ate polar bear liver, that it would be toxic. Um, but anyway, we can see here that also, excuse me, also sweet potatoes. So spinach is one that I'm aware of because I eat spinach. One of the reasons is for vitamin A, and carrots actually have less than spinach, which uh, I think would maybe be surprising to some people because carrots are always thought of as the quintessential vitamin A carrier. But you can actually get more from spinach, and so leafy greens are actually a good source of them. Kale, I believe. I don't know if that's listed on here, but kale, I believe, is a good source of vitamin A. And as I said before, those leafy greens also have chlorophyll, which is why they appear green, but they do also have quite a bit of vitamin A. I'm not going to go through this whole list. Like I said, I just got these from Wikipedia, so if you're interested, you can look that up on your own. All right, so down here, I'm talking about vitamin D. And so vitamin D, as I said, we have this pre-vitamin D here, which is produced from the cholesterol pathway. And so this comes from the same pathway as cholesterol, which is quite often why if you're taking statins, um, it will be suggested that you take a vitamin D supplement because you will start losing this if you are taking statins for cholesterol. And so here we see that the UVB light from the skin turns it into this form here. This is actually a two-step process. There's the bond breaking here, and then there's sort of this change here in the bond structure. But like I said, I'll go through that more in the next few videos when I get to the biosynthesis of vitamin D. Uh, then we have the hydroxylase, which adds a OH group right there. And so quite often, if you get your vitamin D levels measured in your blood, you will often see it as 25 OH vitamin D as what's being measured, and that's because they are actually measuring this right here, which has this OH on the 25th carbon, so that's 25 hydroxy vitamin D3. Um, so what we see here, though, what I want to focus on more, since the biosynthesis I will get into later, is that these things happen at different parts of your body. So this happens in the skin. This photosynthesis. It's using photons to synthesize this, so humans can photosynthesize. But then this is transported uh, to the liver, and so that's why this is sort of a pre-vitamin D. Uh, I guess you could think of. I think this is the type that you usually get from uh, from taking supplements. And so you take that, and then it goes to the liver. It gets hydroxylated on that 25th carbon. Then it can go to the kidneys and to the intestines, and the intestines is where it helps in calcium absorption. And this is what vitamin D is sort of measured for. So the endpoint, as I talked about in the intro to this whole series, is looking at bone health, but vitamin D is involved in a lot of other things. It's actually used quite often as a hormone for signaling for different gene expression. Um, Over here, this is just looking at it in terms, once again, of that calcium absorption. Uh, and so it's just showing that the parathyroid glands, which controls calcium absorption, signals to the kidneys. So that signals for vitamin D hydroxylation in the kidneys, and that is then transported, as it shows here, to the intestines, and that increases calcium absorption in the intestines, uh, and calcium reabsorption from the bones. And so what that means is if we have a lot of calcium in our diet, then we're getting this calcium from the intestines. But if we're not getting calcium from the diet, then it's actually going to just take it from your bones. Uh, and so both of those things, calcium absorption from the intestines and reabsorption from the bones, increases calcium in the blood, which then signals to the parathyroid glands. And you can see it has a negative here. So it's telling the parathyroid glands to stop releasing parathyroid hormone, which reduces calcium absorption in the intestines and calcium reabsorption from the bones. And we can see here that this vitamin D is needed for calcium absorption from the intestines. And down here, I just have once again some sources for vitamin D from the diet. And we can see that fish seems to figure quite a bit into this. You get a lot of vitamin D from fish. Milk, which is maybe a source that people are familiar with, and obviously UV light here. Once again, we have more fish. So fish is kind of a big source of vitamin D. Once again, we have liver here as well. So yeah, fish is just a big source of it. Down here we have our RDAs for vitamin D for depending on different ages. And so this, like I said before, is based on the the end point, the end point of bone health. And so a lot of these are sort of disputed just because vitamin D does so much more than just bone health. And so these these IUs probably look quite small to people who are familiar with supplementation, which quite often you'll see in the 1,000 IU, sometimes 3,000, even as high as 5,000 IU from your supplements. And so these 600 IUs probably seem kind of small, but that's, like I said, based on this endpoint of bone health here. And down here is just if you get your vitamin D levels measured, like if you get some blood work done, um, these are just levels that uh, so levels that so well I guess the 30 to 50 nanomolar per liter, which is 12 to 20 nanograms per milliliter, is normal range. Well, actually, these are considered inadequate. Excuse me. So normal would be the 50, the uh, the 50 here, greater than or equal to 50, greater than or equal to 20. So these are normal levels. So uh, probably between 20 and 50 uh, for the nanomolars or the nanograms. So this is nanomolar and this is nanograms. And then you can, just like with the vitamin A, you can actually get too much of it. And one of the reasons that you can get too much of these fat-soluble vitamins is because they are fat-soluble. They can be stored in your in fat, and so uh, if you get too much of them, unlike with the water-soluble, they don't just sort of wash through and get urinated out. So these can actually be more toxic at higher levels. And so over here, I have vitamin E. As I said, vitamin E is sort of the catch-all term for tocopherol. And here, this is just looking at multiple types of tocopherols. So there's the alpha and the gamma, which are the the vitamin E forms of it. The beta and delta are sort of pre-vitamin E forms of it, and they just differ by where they have these methyl groups uh, on this R1 and R2 here, and these groups here are all on this structure here, which is called a chromane ring, which I have right here, and so it's this aromatic ring here. Aromatic just being uh, the term for a ring that has conjugated double bonds, and it's different in ring form because this gives it sort of this that more resonance stabilization in the ring, and the ring that's an aromatic ring you actually see quite often like this because these electrons are shared everywhere in the ring. Where they put these double bonds is just kind of arbitrary. You could also have put them on these single bonds here and had these double bonds be single bonds. And so quite often you will see these drawn like this. And so over here, this is the alpha and gamma tocopherol, which are the vitamin E, the sort of the active vitamin E forms of this, and we can see this differs just by this methyl group on this carbon here. And we have here just some physical properties of it. The melting point is 3 degrees Celsius. So at room temperature, if you just had like a glass of vitamin E, it would be liquid. And at 235 degrees Celsius, that's when when it evaporates. We can see here solubility in water is quite low. So that's 1.9 times 10 to the negative 6. So that's 0.00000019 milligrams. So if you had this many milligrams, which is a very small amount, that would be the only amount that you could dissolve in a liter of water at 25 degrees. It does say that it's soluble in ethanol, which uh, has a structure that's more like this, and so you see it has this more hydrophobic part here. That's why you can dissolve it in ethanol. And pKa, which would be talking about this hydroxyl here, is 10.8, and we can see that that is lower than what you would think on something like, well, on ethanol, which I believe is somewhere around like 16 pKa, but because of the resonance stabilization in this aromatic ring, this hydrogen is more likely to detach. It's more likely to deprotonate that hydroxyl group there. Um, Over here, once again, we just have some sources and RDAs for different ages. Once again, just from Wikipedia. Uh, so sources for vitamin E are, I think, in people who know about vitamin E knows that things like nuts are a very good source of vitamin E. So we have sunflower seeds and almonds and hazelnuts, peanut butter and peanuts. And so once again, we also see that things like spinach and broccoli, these green vegetables, are good sources of vitamin E. And down here, we see uh, that the amount of vitamin E that you're supposed to get is quite small. Um, it's fairly small, and vitamin E can actually be bad for you, just like all the fat soluble vitamins can be bad for you if you if you get too much of it. So I think it's generally recommended not to supplement vitamin E, especially also because most supplements of vitamin E have just one form of these tocopherols, and you need kind of a nice balance of both of them. And so if you get too much of one and while not getting enough of the other, then that can also be bad for you. Um, and so I think it's just generally recommended that you don't supplement with vitamin E. It's better to get it from the diet. Um, and like I said, you don't need that much of it every day. So if you're eating these kinds of things, then you're probably going to be getting enough of it. Vitamin K is another one where you don't need that much of it from your diet. I'm not even aware if there are vitamin K supplements, because it's not one that we really need. It's not very common that people are deficient in vitamin K, and one of the reasons for that is because vitamin K is actually produced by our microbiome, and so I think it's really only just sorts of some forms of genetic disease and things like that where vitamin K deficiency uh, becomes a problem. Um, anyway, we can see here there are these multiple forms of vitamin K. Uh, there's the phylloquinone and phylloquinone epoxide. This has this epoxide group here. Uh, you'll probably not find this in your diet. Epoxides are very unstable. Um, and then the menaquinone and the K2 and the K3. Um, and like I said, the thing to notice here is that we have these hydrophobic chains on them, which is one of the reason why this is a fat soluble vitamin. And vitamin K is involved in the blood the blood clotting process in humans. The bacteria that produce it actually use it for different reasons that I won't get into in too much detail, but humans have sort of taken it and repurposed it for blood clotting. Obviously, bacteria don't need it for blood clotting because they don't have blood. But we can see here, once again, sources up here. Once again, spinach and kale are good sources. Broccoli is a good source. So these dark green vegetables. Um, yeah, I'm not going to go through all of this, but yeah, if you have a diet that has, I mean, you don't even need to have that much of this in it. You could probably get enough of it with foods down here like milk and cheese and egg and so forth. Because, like I said, the microbiome is also producing this. Uh, Over here, I just have some things about deficiency. Like I said, vitamin K deficiency is probably not one you have to worry about, but uh, these are some of the symptoms that you might see from it. So things like easy bruising or oozing from the nose and gums, excessive bleeding. As I said, vitamin K is involved in blood clotting. That would also affect the menstrual cycle. We can see that bleeding and blood are symptoms of that. Vitamin A deficiency, so dry skin and dry eyes are things you might experience if you have a deficiency in vitamin A. Night blindness, obviously vitamin A is sort of known for being good for the eyes, and particularly night vision. Um, but it can also affect fertility. I think that's fertility is sort of just malnutrition in general is bad for malnutrition nutrition is bad for fertility in general, because if you're not getting enough food, then your body's just going to sort of say, uh, there's no point in conceiving offspring, so let's just conserve energy and shut that down. Uh, but you can also see poor wound healing, acne breakouts, delayed growth, which would be more for children, throat and chest infections, so maybe some immune deficiency. We can go over here to vitamin D deficiency, so excessive sweating, fatigue. Um, so fatigue is probably more because of the things like the hormone function of it. Though I guess calcium as well, since calcium is involved in muscle signaling. Uh, Digestive problems, immune impairment, joint pain, dry skin, again, high blood pressure. So, once again, just like with statins, quite often you'll hear or a doctor will recommend if you have high blood pressure to take vitamin D supplements, and that's supposed to help a little bit with blood pressure, mood swings, weight gain, uh, and so these are all, like I said, symptoms of vitamin D deficiency. Vitamin E deficiency, so cancer is probably sort of the big one. So vitamin E is an antioxidant. So that's sort of its main function is being an antioxidant, and so that is involved in cancer prevention. It's involved in making sure your cells are not too damaged. So blindness can be so once again, fertility problems. Like I said, that's just sort of a malnutrition, uh, sort of something that just happens with malnutrition in general. Immune impairment, leg cramps, once again, dry skin, muscle weakness, anemia, which is low iron, and hair loss. But probably cancer is the one that you'll hear most about, since vitamin E, as I said, is an antioxidant. And so that was everything for this introduction here to the fat soluble vitamins. Like I said, in the next four videos, so the next four videos, I am going to go through the biosynthesis of these fat soluble vitamins. After that, then I will do an introduction like this one here about the water soluble vitamins, and then go through the biosynthesis of the water soluble vitamins. Then after that, I will do some videos on the minerals, and so that's sort of the outlook for the next, well, the next quite a few videos, to be honest. And after that, that's when we will start getting into human metabolism of these vitamins. And so I will see you in the next video.